This is the second of the two videos on pure monopoly. Now in this video we are going to do a graphical representation of a pure monopolist so that we can analyze it and to see how it is different from pure competition. In reality, there are no industries that are purely competitive, no industries that are pure monopolist. We are comparing these two extreme models of competition so that we can determine the relationship between competition and economic efficiency. What we're going to find, what we've talked about already, is that the more competitive the firm, the more efficient. The less competitive the industry, the less efficient. Before I start, however, quick story. In 1956, might have been 1953, somewhere around there, the federal government took DuPont Cellophane Company to court, accusing them of being a monopolist and, with the intent of breaking them up and making them a whole bunch of little firms competing against each other, like they did with Standard Oil. They divided that company into 33 different firms. So they wanted to do the same thing. The Justice Department wanted to do the same thing with DuPont Cellophane, because they were the only seller of cellophane. DuPont Cellophane's lawyer says, no, we're not, we may be the only seller of cellophane, but we're not a monopolist. The reason is that the industry cannot be defined as the cellophane industry. The industry should be defined as the flexible container industry. And so the courts had to decide, okay, what is the industry? Is there a cellophane industry, or is cellophane just part of the flexible container industry? Turns out the lawyers for DuPont was able to convince the judge through the concept of cross-price elasticity, which you learned about in the chapter on elasticity, that flexible containers was the industry rather than cellophane. That is tinfoil and other, wax paper, things like that, as well as cellophane, were all in the same industry, okay, because they were significantly similar. By definition, then, any product outside of the industry is not going to be a good substitute for the product in a particular industry. So, a monopolist is going to produce a product for which there is not a good substitute. And for that reason, the monopolist's demand curve will not be perfectly elastic. Recall, here I have two graphs. Recall that because there were many, many, many absolutely perfect substitutes for the purely competitive firm's product, the purely competitive firm faced a perfectly elastic demand curve. The purely competitive firm faced a perfectly elastic demand curve, which also happened to be the average revenue curve and the marginal revenue curve. Hopefully you remember that. However, for a monopolist's product, there are not close substitutes, and there are not many available substitutes. So because there are no good substitutes, and whatever substitutes there are not perfect substitutes, the demand curve is not going to be perfectly elastic. In fact, the demand curve for a monopolist product is going to be downward sloping. There's going to be an inverse relationship between the price of the product and the quantity of the product demanded. The higher the price, the lower the quantity demanded, the lower the price, the higher the quantity demanded, and by the same token, if the firm produces more, is going to have to reduce the price in order to sell that additional output. If it produces less, it can charge a high price. Remember, the monopolist is the industry. The monopolist produces the entire amount for the industry, and if the monopolist changes its output, the market supply will change. Okay, so now we see that the demand curve for a monopolist product is downward sloping. What we're going to find is that the marginal revenue curve and the demand curve are no longer the same. Here is the price and quantity relationship. Price 10, 9, 8, 7, 6, 5, quantity 1, 2, 3, 4, 5, 6. Notice the inverse relationship. When price is 5, quantity demanded is 6. When price is 6, quantity demand is 5. Price is 7, quantity demanded is 4, etc. When price goes up, quantity demanded goes down. Price goes down, quantity demanded goes up. Let's derive the total revenue. 1 times 10 is 10. 2 times 9 is 18. 3 times 8, 24. 4 times 7, 28. 5 times 6, 30. 6 times 5, 30. Now, oh, that's terrible. But hopefully you know what that says. Let's derive the marginal revenue. When the firm produces 0, obviously its total revenue is 0. When it produces 1, total revenue is 10. So the marginal revenue with the first one is 10. The marginal revenue for the second one, 8. Marginal revenue for the third, 6. That's an 8, I think. 4, 2, 0. So what we see here is that if you can read this, and you get an A for the day, if you can read this. Here is the demand curve. Quantity 1, price 10, quantity 2, price 9, quantity 3, price 8. Here is the marginal revenue curve. Quantity 1, price 10, quantity 2, 8, not 9. Quantity 3, 6, not 8. So if you look at these figures, and it is also derived in the book, what you're going to find is that the marginal revenue curve lies below and slants steeper than the demand curve. Here's the demand curve, like that. The marginal revenue curve will look like this. Matter of fact, it'll even go into the negative quadrant after a while. Notice how the marginal revenue curve lies below and slants steeper than the demand curve. And this picture is illustrated on page 281. The marginal revenue curve lies below and slants steeper than the demand curve. So now, let's take our cost curves. I know you've seen these. And let's impose the demand curve and marginal revenue curve on top of it. Now I'm just putting the demand curve and marginal revenue curve up here kind of randomly. There's the demand curve and the average revenue curve. Here is the marginal revenue curve. Okay? We just impose those revenue curves over the cost curves. Now the first thing we're going to do is look for the point where marginal revenue is equal to marginal cost. It's right there. I didn't draw that there intentionally. That's just where they happen to cross. Marginal revenue, marginal cost. So here is going to be the profit maximizing quantity. Call it Q sub 1. But how many is the firm going to produce? They're going to charge the highest price possible consistent with selling Q sub 1. So they'll draw the line all the way up to the demand curve and over, and they will charge this price, P sub 1. So they will charge P sub 1 in order to sell Q sub 1 at the highest price possible. Okay, I'm going to make a quick little video after this just to expound on this for a few seconds. So bear with me. Check out video number 3. This is video number 2.